Record, share screen. I was looking over the previous things, so the past video quizzes, self-assessments, assessments, because I always like to, especially for the questions where you can sort of fill in the answers, fill in the numbers. Sometimes Moodle will be a little finicky about what it accepts for whatever you write in. Now, just for the people that have already emailed me about this, Moodle is fine if there's a question about something that requires a dollar amount answer. Whether you put the $ in there or not, Moodle should be fine with either of those options. So I think I've complained about this in the past. If you think you got a question wrong because you included a $, or if you think you got a question wrong because you did not include a $, that's not why you got one wrong. And that's probably not that question that you got wrong. At least it wasn't wrong because of the $ issue. But there can still be things where Moodle sometimes will miss things, or especially with Module 2, there was a set of questions about enter in the optimal quantity, and then what would be the total revenue at that optimal quantity, what would be the total cost at that optimal quantity, what would be the profit at that optimal quantity. And some people might have messed up in one or more of those questions. So they might have made a mistake on what they thought the optimal quantity was. And that would have marked you wrong for that one, but it probably would have marked you wrong for all of the rest of them too. Because if you thought that the optimal quantity was X when it should have been Y, then presumably you would have derived your total revenue, total cost, and profit based on X when you should have done it on Y. Well, I go in and I manually check because I go, well, if this is the equation for total revenue and if this is the equation for total cost, then plugging in their wrong answer for the quantity, if the formula gives me a total revenue that's the same as what they wrote down, even though the answer they wrote down wouldn't be wrong, it would be correct based on their previous wrong answer. So I gave, like I said, about 2 minutes before we started tonight, I just finished going through all the past week 1 and week 2 things to try to give some partial credit when I could. That can sometimes turn around and bite you in the butt though, because it might be, maybe you put in the wrong quantity, the wrong optimal quantity for the first question. And then later on, maybe by some miracle, you actually got the correct total revenue on my answer key. But it wouldn't be consistent with what you wrote down as your quantity. If I used your quantity, I would get a different total revenue than what you actually typed in, even though what you typed in was technically the correct answer for the question. So I manually check those too, and I go, should I take away some points where it wasn't actually deserved? But I think for this one, at least for all the ones that I looked at this time, almost every time it was a situation of giving partial points. So if you were to go in and look at your Module 2 score again, it shouldn't be lower and it might be higher. So you can go and check that out if you want to. I can see that. And so I also posted the overall scores, so you can see and again, my Moodle screen looks a little different than yours. I have some hidden stuff that you can't see, but you should be able to see in Module 1, this Module 1 overall scores and Module 2 overall scores. So that'll give you kind of a sense of how the class performed on the different things that week. So the different video quizzes, self-assessment, assessment. So I give you the class average, you have the number of people who scored in certain ranges of scores. So kind of things like that. We're supposed to give you some basic general feedback on how you do on these things. So that's my attempt at doing that. But all right, let's see. So questions. Let me go over here, and everyone's going to have questions about the assignment, I assume. So for assignment Q2, for assignment question 2, doing the regression, price is Y, quantity is X, correct. For part A, yes, I say run OLS to determine the demand function as P is a function of Q. So yes, your P is your dependent variable here for part A. Your Q is your independent variable. Let me, sometimes I get a little thrown off because I have I have 2 monitors here. And I know sometimes if you only have a single monitor, it'll put everyone's face from Zoom over on the right-hand side. So we try to move stuff in the middle. So yes, P is your dependent variable for this regression. and Q is going to be your independent variable for this regression. And this is kind of standard notation for, well, talking about any kind of equation. If you have, something is a function of something else, that means that this variable over here depends on or is affected by these variables. So yes, P is your dependent variable or your Y, and then Q, and it could be more than just one variable. It could be Q and other variables in there too. But anything kind of inside this parentheses of the function, that means that these are the independent variables. Also for Q2, when rounding total revenue to the nearest dollar, should you assume you mean round up? When I say round, where do I say that? Oh, here we go. Round your price to the nearest cent. Essentially, what I usually mean, let's see, this one will probably do it. The easiest thing for me to remember when I'm rounding is to go, okay, these are my P's. If I didn't round these things, and if I said, okay, well, round this to the nearest dollar, then I would just take my Excel and I would go, okay, well, I'll have Excel do that. I'll just bump my little decimal places over so that it's only showing to the nearest dollar. It's not showing any cents there. So that's the easiest way for me to do it. It could mean that you round up if the decimal point is 0.5 or above, or it could mean you round down if the number after the decimal point is 4 or lower. So just round to the nearest dollar. But again, for me, it's just, I just have Excel do it easily enough. Okay, so there's those questions. Could you please discuss what we should look for when seeing if correlation is useful for these seasonal adjustments? Or should we look for something else to see if seasonal adjustment is useful? It's going to be kind of a situation where, so this is question 3. This is a question 3 question. So I'm having you look at the sales for these things, and you've got your seasonally unadjusted data and your seasonally adjusted data. And I have you do a couple things after that. Have you figure out the correlation between those two data series, the unadjusted versus the adjusted monthly data. So you have this idea of this correlation, and if you don't remember what correlation is, you just go and look on Wikipedia or whatever to figure out what we mean by correlations. Scatter plots, so you'll have, and I have, to draw the straight lines between them, it makes it a little easier to see what's going on. So you'll have this correlation that will tell you a little bit about what's going on. You'll have these scatter plots that will show you what's happening with this unadjusted and adjusted data. And so I say, do you think making a seasonal adjustment will be useful given what you observe at this point? So basically what that means is, do you think once you look at this seasonally adjusted data, does that tend to be a helpful adjustment? Does that tend to be a helpful thing to do? Do you think it will be useful given what you observe? So you kind of, you can use what you see when you find the correlation. You can use what you see once you generate these scatter plots. So you can say, the correlation and the scatter plots suggest to me that blah, blah, blah. And up to that point in the question, that's all you've done. You've just done the correlation and you've done the scatter plots. When I ask this question here, that implies that you haven't done the regressions down here yet. So you should be able to answer this question just based on what I've done in this particular paragraph. For question 4, do you mean formulate hypotheses? Hypotheses, I assume you mean, not formulate hypothesis, because that's a singular. When I say, now assume that what are the values? You actually don't have to, well, I guess here, maybe you do. Because in part A, I say discuss whether you think these regression results will generate good sales estimates. So part of, again, there's a few things that go into whether you think regression results are good or not. So you might want to review some of the discussion we had about interpreting regression results. Part of that is, part of that does depend on analyzing the results you're getting for each independent variable. And so that may involve you saying, well, I think the coefficient should be this, and I think it might be the sign, and blah, blah, blah. So if that's usually what we mean when I hear the phrase formulate a hypothesis. To me, that generally means, do you think that this coefficient is positive or negative? So you might have more of an intuition beyond even that. You might think, well, I think that not only do I want to predict the sign of the coefficient, whether it's positive or negative, but I'm going to predict the size of the coefficient. that might be beyond what we're used to doing. So it's enough for me to think before I run this regression, I should come up with an idea in my head about at least what I think the signs of this thing are. And then I can look at my results and go, okay, seems to be consistent with what I thought. Question 4, part C, we should use the formula from lecture 2, slide 4. Possibly. That's for you guys to decide which formulas you should use. Question 4, parts D, E, and F. Is there an example of how to calculate these? There is a discussion of what these elasticities mean, and even here, as I'm just kind of looking at my answer key over here, there's an example here. So I have this elasticity of this negative 4.98. Gotta give a little bit of a discussion of what that means. So a 1% change in price will result in a negative 4.9% change in the quantity. So it's left in kind of a very general applicable way with both row 29 and row 35 of the part of the second practice problem answer key. You see the elasticity value there, and that means that and I think I mentioned this in the video, if not the slide, that the values of these elasticities allow you to make a sentence like this. A 1% change in the price would result in and whatever that value is, change in the quantity demanded. So in this case, since the elasticity is negative 0.9, then a 1% change in price would result in a negative 0.9% change in the quantity demanded. And there was a similar sentence up here in row 29, just a different value of elasticity for that one.
So Professor, so that means a 3% change, multiply this percentage by 3 of NQ?
That would be for you guys to decide on your own, whether you think that's an acceptable extrapolation. I'll let you guys.
Okay.
See, I get a little more cagey when you guys ask me questions about the assignment itself. Let's see here. Okay, so I'm on this question. Could you please explain assignment question 3 where make a new column of seasonally adjusted monthly by dividing annual data by 12? Let me go get that data set so I can show it to you. Let's see, we're on week 3 now, and that's the housing data. Well, you guys might not have actually wanted to do this, to go into this much detail. Do I link to it? Yeah, I did. See, because I didn't want people to get messed up, so I said I have recreated the data in this Excel sheet here. So I imagine most of you probably just went and clicked on that, but just to show you that I wasn't lying to you. And I had to also double check because I've had situations in the past where I've taught this class, and when I made my answer key and when I wrote out all the questions and wrote out the potential answer keys, I was looking at a certain release of the data, and then between the time I made the answer key and the time that students actually took the test, they came out with a new version. So everything was messed up because they were looking at the latest set of data. But we're okay here because the next release is November 25th, which is well in advance of what we're doing for this assignment. But I can show you the Excel data here. So that sold cust tab or on the sheet. So here's the data you actually get. And I trimmed it down in the sheet that I made available to you. I trimmed it down quite a bit in this census housing data file. But you can see that we have data here for houses sold by region, annual data. But this also says sold during that particular period. So, I got to go to my reg sold tab. There it is. Now let me make this bigger too. Houses sold by region, sold during the period. So here they're going to say, the period was January 1963, February 1963. Let me go to where we actually have some. Well, I guess we just need the US. But we have our not seasonally adjusted data here. Okay. And we have our seasonally adjusted data on this side. And I said, well, we're not actually going to use any data from the Northeast, Midwest, South, or West, so I'm going to delete that, and I'm going to delete that. So now I just have the not seasonally adjusted data for the US. And this other one says seasonally adjusted annual rate. And if you watch data, if you look at data, or if you look at government sources that cite data, that produce it, or other places too, that produce data, sometimes they'll slip this in on you. They'll talk about something at an annual rate or an annualized rate. A lot of times they'll do this when they talk about inflation or unemployment too. They'll say, well, especially with inflation, they'll say inflation in September or October was 2% at an annual rate. And you go, well, I remember buying stuff at the beginning of October, and it wasn't 2% more expensive at the end of October. It was, maybe a little bit more expensive, but certainly not a whole 2%. Well, when they slip in that phrase at an annual rate or an annualized rate, they're saying whatever the rate was over that month, if it were to grow like that for the rest of, for an entire year, then that rate would be 2%. So it's essentially, if they say it's growing at a 2% rate annually, then if you just want to find out what the growth rate was over that 1 month, you take your 2% and you divide it by 12. So it's a little confusing because they tell you for the not seasonally adjusted data, they're essentially telling you what was sold during that period. So in January of 1963, there were 42,000 homes sold during that 1 month of January of 63. But then you go to the seasonally adjusted data, and you look and you go, man, that's really far off. That's quite a ways off. 591,000 homes sold in just that 1 month. Well, again, that's because they're doing this at this annualized rate. So you would interpret that to mean, I know that homes sold at a certain rate, a certain speed during January of 63. And if it would have continued like that for 11 more months, for an entire year, then there would have been 591,000 homes sold during that entire year. So if you're just trying to figure out, well, on a seasonally adjusted basis, how many homes were sold just during that month, then you have to go, well, let me take this annualized rate and just divide it by 12. And you get a number that is not exactly the same. I mean, the whole point of doing the adjustment is it's not going to be exactly the same, but it's certainly a lot closer, a lot more comparable. The 42 and 49.3 is a lot more comparable than 42 versus 591. So that's why I end up having you do the taking the annual data and dividing it by 12. So now I've got not seasonally adjusted data that was sold just during that month. And now I have this seasonally adjusted data that was also just sold during that month. So it's more of an apples to apples comparison when you take that annualized data and divide it by 12 to make it kind of like a monthly data. So that's why I'm asking you to do that. And that's why the seasonally adjusted sales, this seasonally adjusted sales is 12 times bigger just about than what the not seasonally adjusted data is. So Carrie and Jeff's questions are close to the same. What is the government doing on that adjustment to result in a log change in the number, basically? Well, again, my guess is that they're not actually doing anything with logs. They're just taking that rate and multiplying it by 12. And they're doing other things too. They're doing other things to do their own seasonal adjustment. Like I said, I'll be a little cagey and let you do the question and play with the different regression models that I'm asking you to do. Because again, part of the question is to say, including this D variable, does that do a decent job of accounting for the seasonal effect? So hopefully that helps with both of those two questions. Are elasticities always negative? They don't have to be. Let me open my, close some of this, jump down, figure out which of those two slides that's going to be more appropriate. Especially if we're talking about the income elasticities or the cross price elasticities, those certainly do not need to be negative. In fact, the signs of those things, we use the sign of those things to figure out whether something is, like I said, for the income elasticity, whether it's a normal good or an inferior good. So we certainly do care about the sign when we're doing income elasticities, because that tells us whether the good is a normal good or an inferior good. And we certainly do care about the sign for cross price elasticities, because that helps us figure out if the two goods are substitutes or complements to each other. And I suppose it's possible that just the regular standard elasticity might be negative. But as I say here, because of the law of demand, we assume that it usually is. Now, there can be other things happening, and maybe we should say everything else equal. We would assume that, I mean, the law of demand does also say, it says everything else equal, if the price goes up, quantity demanded should go down. Well, again, in the real world, everything isn't always equal. So you could have situations of, well, it was the first week's question, right? When we did the movie theater thing, it was like, why do people buy so many more tickets when the price of movies is high? And they don't buy as many tickets when the price of movies is low. That seems to go against the law of demand. So if you would have maybe tried calculating elasticity there, and you go, okay, I've got these two prices. I've got this, Tuesday morning price, and I have this Friday evening price. Those are two different prices, and they're quite a bit different for these movie tickets. And what I'm seeing is when the price, if I think about the price going up from its Tuesday morning price to its Friday night price, that's an increase in price. I'm also seeing an increase in the quantity demanded. So if you were to calculate an elasticity over those two data points, you would end up seeing that the elasticity is positive, which we wouldn't expect. But that's because everything else is not being held equal. So we usually assume that these things are negative. But again, for certain data sets, if you're not accounting for everything, if there are other things happening in the world of that data, then you could end up getting elasticity values that aren't necessarily negative. Usually when you see reports like in a textbook, or when you see economists talk about the elasticity of gasoline or the elasticity of cigarettes or something like that, then they're usually trying their best to control for everything else. And usually that's why they report elasticities as being negative most of the time. But again, especially with question 1, you're going to run across some elasticity values that are actually positive because there's other things happening. There are other things that students are worrying about besides just the tuition in terms of what the choices that they're going to make. So don't freak out if that happens. How to calculate total revenue in question 1 of the extra assignment. Extra assignment. You mean the practice problems? I hope I didn't give any extra assignments. Let's see here. This one was just, so this one was that. But calculating total revenue in question E. Oh, down here? Or is it in this one here? I don't see any total revenue questions for either of those, although I say determine the equation for marginal revenue, which means you have to have an equation, I guess for both of those. Determine an equation for marginal revenue, and you have to know the total revenue to be able to take its derivative to get an equation for marginal.
So I think you're talking about the second question in assignment E, the E part.
Okay. Well, as I was looking at them, they both kind of ask similar things. So determine an equation for marginal revenue as a function of Q. And even in this one, it does sort of the same thing. Determine an equation for marginal revenue as a function of Q. So they both kind of ask similar questions. And for, let's see, for the first problem, zoom in again. You have the, let's see, use calculus to find the number of haircuts. We find the demand curve, well, even above that. Okay, so you've got your demand curve way up here. Yeah, maybe it is asking for the practice problem number 2, because I sort of talked about it at the very beginning up here. If you know P is P as a function of Q, so the demand equation as a function of Q, and you know total revenue is P times Q, then you can take this P equation here, multiply each of the terms by Q to get an equation for total revenue. So 20 times Q is 20Q. Negative 0.2 Q times Q is negative 0.2 Q squared. And then from there, to get marginal revenue, you have to take a derivative. Take the derivative of total revenue with respect to Q. So the total revenue of this TR equation with respect to the Q variable, well, there's 2 terms there. So the derivative of the first term with respect to Q is just 20 coefficient. Derivative of the second term here is, well, it's being raised to the second power, so I got to do 2 times the 0.2, or negative 0.2. So I get a negative 0.4. And then it would be q to the first power, the 2 minus the 1 power. So q to the first power. So I get an equation for marginal revenue right there. And I did actually say, I guess I got my things out of order. Because I say determine equation for marginal revenue as a function of q. We did that way at the top. So, so then for the second question, second practice problem, same sort of thing. You're starting way up here, and I tell you to run OLS. Does this look familiar? This question here look familiar? Run OLS to determine the inverse demand function P is a function of Q. Does that look familiar at all? So, just pointing it out. So you got this demand equation here. P is a function of this intercept term, a Q term, and then to get an equation for marginal revenue, you have to do sort of the same steps. So you need to know what the total revenue is. So I sort of describe that here in part E. So total revenue is P times Q. I have an equation for P up here. So I'll just take that P equation and plug it in parentheses here. That's the P. And then I'm still multiplying it by Q. So each term gets multiplied by Q. Take its derivative to get marginal revenue. So you get, over here, I'm just trying to figure out for myself what 0.00836 times 2 is. So I've got my equation for marginal revenue here. And again, so you're deriving it. You have the demand equation, and your demand equation has to be a P as a function of Q, because total revenue and marginal revenue are always in terms of Q also. They're not, you don't have total revenue equals something with a P in it, or marginal revenue as something with a P in it. They always have just Q terms in them, which means that's what you end up having to have an equation, a demand equation, that is P equals something with a Q in it, so that I can later on turn it into a total revenue equation, a marginal revenue equation. But for the elasticity stuff, you need to also have your demand equation, which is Q as a function of P, Q something with a P in it. Because you need to be able to figure out this dq dp, the derivative of the Q equation with respect to the P variable. So you need to be able to flip these demand equations around to play with them in whatever context you need. So does that help a little bit more with the how you calculate total revenue in those couple questions, practice questions?
Yes. Does the confidence just come from the p-value, or is it also from the r-squared?
The confidence in the, kind of depends.
In the equation.
Confidence of the overall equation. I mean, when I can use confidence in a fairly strict sense, where we say, how much confidence do you have in this coefficient? Like, is this a statistically significant result? Usually that's how they talk about confidence. Or this variable was significant at a 10% confidence level or 10% significance level. So if they're using it in kind of more strict sounding sense like that, then it would be looking at the t-stat, looking at the p-value. If in general they're saying how much confidence do you have in your equation, then yeah, maybe they're talking about everything. Maybe they're saying, well, look at your r-squared, look at your p-values, look at your t-stats, look at your signs and these things. If it's a really general question, how much confidence do you have in this equation, then you probably have to talk about a couple things. If it's just, do you have confidence in this coefficient being significant, then you can say, well, really all I need to talk about is the p-value or the t-stat in that case. Let's see here. Still trying to get through these questions. Good questions. In question 1, do we calculate separate elasticities for undergraduate enrollment and total credit hour? Yes, because I wanted to not just have you look at one thing. So it's, elasticity is the percent change in the quantity demanded divided by the percent change in price. So if we're thinking about students going to school and their demand for college in a really general sense, then, well, pretty easy to think about the price of going to college, and that's the tuition. So I have your tuition there. as I say, you'll have an elasticity of price versus headcount and one of price versus credit hours. So the price in both of those cases is the tuition or the price of the credit hours. But then how much quantity how are you measuring the quantity demanded in terms of college education? And you could probably think of a couple ways of doing that. And some, colleges usually look at a couple ways of doing that. They'll look at how many students do they have. How many students did they graduate is another way of thinking about it. I didn't have you do it here, but what's the retention rate? How many freshmen want to stay on and become sophomores, or sophomores want to stay on at that same school and become juniors? Again, how many seniors end up graduating? How many freshmen actually stay the whole time and graduate? All of that can kind of be thought of as measuring the quantity demanded for the school. So I had you look at two things that seemed pretty straightforward. The head count, which is just the number of students. But I thought, well, again, you could look at just the number of students. But another thing is that a student might be there. You might have one student that's taking 2 classes per semester and another student that's taking 6 classes per semester. They would still count as the same student, or they would each count as one student. So the head counts would be the same. But the number of credit hours they take would be quite different. And again, usually tuition, they have some fees, I guess, that are usually just on a per student basis. So if you're a student here, every student pays a certain dollar amount for like parking or something. And it doesn't matter whether you take a bunch of classes or hardly any classes, you just pay the same per student fee for something like that. But for other stuff, like especially taking classes, then they charge tuition based on credit hours. So if you take a relatively small number of classes, then you're going to have a small number of credit hours and you won't have much to pay as far as that goes. If you take a lot of classes, then you're going to have a lot to pay in terms of what you're paying for your credit hours tuition. So, but again, to me, both of those kind of represent people's demand for a college education. So that's why I wanted you to look at price versus headcount, or price versus the number of students, and then price versus credit hours, price versus the number of classes that they're taking. So again, I'm just trying to get you to think about the demand for college education from 2 different perspectives. So you will have different elasticities for both of those. As I said, an elasticity of price versus headcount and an elasticity of price versus credit hour. So, and I think I'm answering these questions, and I go back, and the question that I just answered is a lot higher on the chat screen. So I'm like, but that's good. You guys are asking questions. Why would a price as a function of Q regression or any creative form of P? That's okay. Yeah, another good question. So since I'm asking you to, like in the practice problem, I tell you to run a regression to get P as a function of Q. And then I say use algebra to find Q as a function of P. And so that's what I did up here in part A, rows 19 to 22. You start out, you run a regression and you get some numbers here, which you use to form this equation. Then you do a little bit of algebra and you get this equation. And the question is, well, what if I ran a regression with Q as the dependent variable and P as the independent variable? What if I tried to run a regression like this, but then I'd have a P here and Q would be my dependent? Wouldn't that should give me this exact equation, right? And my answer would be no, if the R squared is not 1. If there's any sort of, if this regression equation is not explaining the data perfectly, then if you run a regression kind of the opposite way, then you're going to get results that might be kind of close, but they're probably not going to be exact. The closer the R squared is to 1, then the closer the other set of results is going to be to this equation here. But if it's not exactly the same, then your equation is not going to be exactly the same. Because again, there's a little bit of wiggle room, I guess, in the data if it's not being explained perfectly well. If this R squared is anything less than 1, then algebraically manipulating it is not going to give you an equation that's exactly the same as this one. Again, if it's 0.98, I didn't do it. But if it's 0.98, it should be kind of close. I mean, I guess I could do it pretty quickly, couldn't I? So if I did data analysis, and watch, it's going to be way off, just to spite me. So I'm going to do Q as the dependent. P as my independent. And I got my values, my labels, I mean, and I will spit out the data over here somewhere. So my little equation was Q equals 6,038 minus 119.603. And what I get here is a little different, not too far off. I guess too far off is in the eye of the beholder. So doing the, what is this? Running this regression and then using some algebra gets me an equation of Q equals 6,038.5 minus 119.603 times P. Running a regression with Q as the dependent, P as the independent, gives me a different set of results. Instead of 6038, it's now 5998. They're pretty close enough for government work, and I'm a government employee. The P coefficient, negative 119 versus negative 118. And yeah, they're not exact. You do notice though that the R squareds are exact. You see that? And the adjusted R squareds are exactly the same. The P values are going to be different because they're being kind of measured differently too. Oops, let's see. Yeah, I mean the T-stats and P values are being measured a little differently because the data is different that it's deriving it from. But again, you know, they're fairly close. If you had a different set of data and you had a regression where the R squared was maybe 0.7, 0.8, somewhere in there, then you could do those two regressions and do algebra to the one of them, and the equation would be a little bit further off than what these are. These are pretty close, but certainly not exactly the same. But that's why if you get an R squared that's exactly one, like all your data lies perfectly on a line, then algebraically manipulating isn't going to make a big deal. You're going to, if you ran a regression the other way, it would give you the exact same set of results. So, good question there too. Okay. Yeah. So we did this, and the coefficients are close, but not the same. Yeah. So again, question 1 is much of a problem. Oh, so yeah, if you you know, I tried giving you in the question, I tried telling you what your first set of numbers should be. So your first elasticity for tuition versus head count should be negative 1.113. The first credit hour elasticity should be negative 3.217. I will say that when students have had questions about this and said, I can't figure this out, I'm getting something weird. And when I go and I look at what they've tried, a lot of times what they might have done, and I have a sheet number 2 here, which is just like I say, how to calculate elasticity in Excel. I've got different prices here. These are the same prices and quantities as the practice problem, but I just wanted to show people how we could calculate these things. If you look at column H, which is me just kind of calculating the elasticities directly, you can sort of see I sort of break things down piece by piece over here. So I have just the change in Q, the average of the Qs, the change in P, the average of the Ps, and then calculating elasticity using these 4 things means change in Q divided by the average Q, all of that over the change of P divided by the average P. And this one is just doing it directly. So I have my change of Q here divided by the average Qs, and then the change of Ps here divided by the average Ps. A lot of times if people say that they think they've messed up, it's because they might have done something like this. Like they type in the formula one time and they say, well, I don't want to have to type this thing out a ton of times. And so I'm just going to kind of copy and paste over all my data. And they've gone, okay, you know, here's where my data started. I started with this 44 and the 642. And so they calculate over here somewhere, they run this, they figure out this equation somewhere, and they just kind of copy and paste the formula in a lot of other places. Well, if I look here, it says the elasticity is 1. But if I look at my formula, it's actually referring to something that isn't even data at all. It's just referring to these blank cells. So a lot of times people will kind of make that mistake. They'll just sort of copy and paste everything and think everything is fine. But if your little equation is referring to different cells, you have to make sure it's actually referring to cells that actually have data in it. that you need. If I would have put my P and Q here, it would have not liked it at all. It says, no, I don't like that because your equation is trying to use this P and the Q. So I didn't like that. I don't know if that's any mistakes that any of you are making. If you're not getting the numbers that I showed here, then it may be something else. So, and again, I feel like I was generous enough in telling you this is what the numbers I got are. So I don't want to say anything about, well, yeah, I think what you got is pretty good. So I'm not going to comment on that. Is the data for LSU is given for students and credits real data? It is actually. I went in last night just to verify. I went over and looked. I think I do show you too. You can go look at yourself. I have the links there if you wanted to go look at it yourself. It is true. Why would, in the past years, would credit hours per student? Well, careful, it's not credit hours per student. It's total credit hours. So I guess I could have been a little clearer about that. It's not the credit hours per student. I mean, you can see the credit hours numbers, they're huge numbers. They're in like the tens of thousands of credit hours. And so most students don't do that. So it is the credit hours for everybody. And of course, if the number of students is growing, you would expect the credit hours to also grow. But, it wouldn't have to be on a one-for-one thing. You could have more students, and maybe those extra students are more part-time students, and so they don't take as many credit hours. Or, I don't know, people that really like your school, and not only are the number of students growing, but maybe each student is taking more credit hours than they used to. So it is true, but again, yes, it's not credit hours per student. It's all credit hours for everybody taken together. Data for the past few years of range. So it was real data. I don't know if I can download it again and look at what's going on. I can see what I can actually say about it instead of giving away too much. I do have a hypothesis that we were talking about, generating hypotheses about why things are changing. So let's see. So you do see the number of credit hours picking up quite a bit, especially near the end there. And even just the enrollment too, picking up a little bit. I started teaching more online over the last, couple years or so. And so just the fact that students don't actually have to see me in person, that might encourage them to take more classes. So like, hey, I don't even need to look at that guy anymore. A bonus. So that's my hypothesis about that. This is the credit hours. If you look at the graduate stuff, if you look at the graduate enrollment, which is available at those links, it's completely crazy just because of all you guys and your peers and the MBA program growing like gangbusters. Gangbusters. One of those words you're like, who came up with that? There must be something that went, and there must have been a gang or people busting up a gang. I guess those would be cops trying to bust up a gang, and maybe they do that with lots of energy and gusto. So if you go like gangbusters, you're like those cops that are busting up the gangs. That's what I think about at 9:47 when I've gone through the list of questions. You also, I think for my intermediate class, this is the house stuff. Did I close my, yeah, I closed it already. Where'd that go? I think I have my my undergraduate intermediate macroeconomics class. I have them look at enrollment and credit hours compared to the business cycle. Or maybe that was a question I asked you guys. I don't remember if that was it or not. To think about what happens to enrollment, what happens to people going to college essentially, and does that depend on where we are in the business cycle? When the economy is going through an expansion period, a booming period, do you expect more people or fewer people to be attending college? When we go through a recession, do we expect more or fewer people to be attending college in those periods? It's kind of an interesting question. Could you please go through creating the elasticities for the sample data? Okay, that was my other, let's see, my answer key, which was here, right? Yeah. Oh, tired. So I had a couple. If you look at the answer key, this one was just, this is from last night's Zoom. So the answer key that you would download, get rid of some of these others so they're not in the way. The answer keys that you would download has the answers for practice problem number 1, practice problem number 2. But there are these other sheets in here. It kind of bugs me if you download data from a government source or some other place. If there's an Excel sheet that you download from someplace. I don't know, it's been a while since I've checked this, but it used to be when you would start a new document in Excel, they would always have 3 sheets on it. You'd have sheet 1, sheet 2, and sheet 3. And it always kind of bugged me if you would download data from someplace and it was only 1 sheet of data, but they would still have sheet 2 and sheet 3 there. And I don't know, I just like, why don't you just delete those? Can you get rid of those for me? It just makes me feel like things are neater if there's no extraneous, unnecessary sheets on your document. But sheet 1 and sheet 2 are just here to kind of show you, as I say, I just wanted to show you how to use Excel to do the elasticity problem, elasticity formulas. So I gave you 3 different examples of, I just made up these quantities and prices here. And so, again, the elasticity formula is the change of Q over the average Q divided by the change of price over the average price. So I did, okay, well, let me find and the change of Q over the average Q is the percent change of Q. The change of P over the average P is the percent change of P. So if you're on sheet 1 and you go to cell B6, you can see that I'm trying to find the percent change of Q as the difference or the change in the Qs divided by the average of those Qs. So this big formula here is finding the percent change of the quantity. This formula here in cell B7 is finding the change of the prices, or the difference in the prices, divided by the average of the 2 prices. So this cell B7 is finding the percent change of price. And then you just do percent change of Q divided by the percent change of P. And here it is, make the decimals a little smaller. 143. Now, why is it that massive? Oh, I guess because they're putting it in a percent term. There we go. If I don't put it in a percentage term, then again, you get this negative 1.432. In cell C8, I just did all of that equation in one step. So you've got the, actually I did it a little bit weirder too. I'll do this one over here. So here's my B5 minus B4. So the change in the Qs divided by the average of the Qs. All of that divided by the change in the Ps over the average Ps. And you get the same number. What I did here, sometimes you'll see this if you look at, if people write out equations for elasticities on different websites and stuff, they might do it in either of these ways. They might do the change of Q over the average Q divided by change of P over the average P. Or you can actually, multiply these things and do some more algebraic manipulation where you get change of Q over the change of P times average P divided by the average Q. Algebraically, they're exactly the same, and sometimes you'll see those formulas written that way. I tend to like keeping it like this, just to kind of keep my Q's together and my P's together. I think that's a little clearer. But, so I give you some other examples on sheet 1 of how to calculate those things. Sheet 2 does something similar, but again, I kind of break it down in a more step-by-step way. Well, you have this table set of data like this, and you've got, what is the elasticity between the $44 price and the $42 price? And so I figure out how you can, or I show you how you can figure that out. What's the elasticity between the $42 price and the $26 price? Figure out the elasticity there. So again, between the $42 price and the $26 price, the quantity demanded rose from 1108 to 2932. And so you can say, okay, well, the change of Q was that, the average Q was that, change of P was that, average P was that. The elasticity is all that mess. Figuring it out in just one step, all that mess, same result. So calculating elasticities using this set of sample data. Again, you have, and I'm doing it, I'm figuring out an elasticity between each row, between each period, or between each set of prices. It'd be, you could just as easily say, well, what about the elasticity between if the price were to change from $44 all the way down to 10? So all I might be looking at would be this row of data, $44 and 642 units versus $10 and 4,821 units. You could do that too. You could figure out the change in Q between 4821 and 642, the average Q, the average of those two numbers. So you could do that as well. I just wanted to figure it out between every single row that's here. And I do actually tell you to do this in here. Calculate calculate annual elasticity. There it is, the second word. Calculate annual elasticities. So in the data that you have, it's what are the years? It was 1980. So 1989, 1990, 1991, 1992. So you'll have an elasticity between each year. So it's not like I'm telling you to figure out just the first year and then the very last year and figure out the elasticities between those. Now you'll have between the first year and the second year and third year and fourth year, just like I'm doing here. I have an elasticity between the first row and the second row, another elasticity from the second row to the third row, another elasticity for the third row to the fourth row, all the way to the bottom. So is that a little clearer on the figuring out where these elasticity numbers came from? Okay. Let me go with problem 3 in the practice. Problem 3? Do we have a problem 3 in the practice ones? We have chapter 6, questions 1 and 2, and we do have chapter 7. Only one slide for that, so I'm not sure if that's what we mean. Maybe. So yeah, you can let me know if this. Okay. So just that question. Let's see. Where's the time? I don't think I pulled the answer key up here. And this one is going to be probably. Well, I guess it might depend on how far I go. Sometimes people will go and they ask me to update the data, and I don't know if I have. In the last numbers are here, 2017. Well, I tell you to get the answers anyway, because I think I did ask people to go to Fred and get this data themselves, but then they're always like, your answer key was out of date. I'm like, I got to go in and update the answer key again. So I just told you to get the answers, look at the e-commerce tab, and copy just the date, seasonally adjusted, unadjusted data. So column A, B, and C, these guys, and then do the rest of it. Look at a scatter plot. Notice anything? Make a column from T to 71. Make a Q4. If I look at the data, it looks pretty. Let's see. This is the not seasonally adjusted. So it's got this nice, kind of nice, pretty linear trend line to it, which is why I include the T in there. When you have stuff that has some curvature to it, like a quadratic function usually has some curvature to it, then you might want to include a t-squared term. But we don't have that in the practice problem here. Make a Q4 dummy variable that is equal to 1 during the month 10 and 0 otherwise. Why did I do that? Is this data on Halloween sales during October? This is e-commerce, isn't it? I don't remember why I did that. Oh, it's just Q. Oh, because this is quarterly. That's right. This is quarterly data. So I wanted to try to account for what's happening during the Christmas season. during the fourth quarter of the year. So we had Q4 for that one. Monthly recession dummy. Yeah, so I had this e-commerce is quarterly data, and I wanted to try to account for Christmas sales. So for quarterly data, you have to say, well, Christmas occurs roughly in the fourth quarter of every year. So that's why I have the Q4 data being a 1 during the fourth quarters. But when you go to these other tabs, these are monthly. So then I had to figure out, well, Q4, the fourth quarter on monthly data, is going to be October, November, and December. That's why I decode it that way. But let's see. Report a forecasting equation that you think is best. So you have, you're trying to explain, provide forecast of sales but not seasonally adjusted for those. These are all, let's see, yeah, these all have the not seasonally adjusted data as the dependent variable. And you got to put a couple different independent variables you could think of. You do not want to include the seasonally adjusted data as an independent variable, because you'd be trying to explain what's going on with your not seasonally adjusted sales by being affected by the seasonally adjusted scale. So it's like you're trying to explain the same thing. And you're going to get results that you're going to get an R-squared that's probably through the roof, but it's not really explaining much. It's like, how can you tell me the factors that affect how tall someone is when you measure their height in inches? And you go, do I have to worry about the people's nutrition or their genetics or no, you just have to measure their height in inches. And that does a really good job of telling you how tall they'll be in centimeters. It's like you're using one factor to explain the exact same factor, just measured in a different way. So you don't want to include your not seasonally adjusted as a dependent variable and also include your seasonally adjusted as an independent variable. But there are these other variables that we created. So you've got the T term, you have the Q4, the fourth quarter, you have your recession dummy variable in there too. And I just made some different attempts, some different models here. I actually did not do Q4 versus recession or T in the recession. So just a couple different models that I played with. Let's see, then I said, report equation that you think is the best. So again, even the ones that I listed here I didn't exhaust the possible combinations of independent variables that you could have picked from. You could have done NSA versus just T. I guess I did that there. NSA versus just Q4, or the NSA versus just the recession variable. Or you could have done NSA versus T in the recession variable, Q4 in the recession variable. So I just picked a couple of them. And again, you could have done some that were different from the ones that I picked. Report what you think is the best. Again, whatever you think the best is could depend on your R-squareds, the signs of the coefficients, whether they made sense. So here I'm getting, I see the sales data. It seems like as time goes on, sales increase. So I would expect, since that's sort of what I coded my T variable as. So as the years go by, or as the quarters go by, then the T's just tend to increase steadily. And so I would assume that the T should be positive most of the time. And it is for all of these. It's pretty stable too, 1350 something in almost all of these. So that's kind of nice. That happened to be true. It would have been weird if I would have seen data like this. My scatter plot would have looked like this. So as time went on, the sales went up. It would have been really weird if the T coefficient was negative. That would have been strange. So luckily it's not. I could have probably lived with it if it was negative and insignificant, because then I could have said, well, there's always a chance that the T variable doesn't matter. There's always a chance that the real effect of T on NSA is 0. And it just so happens that, Excel is not going to tell you exactly 0. It might, based on what the data is, it might end up falling a little bit on the negative side. But luckily it didn't do that here. I would expect that if this is e-commerce sales, and we're already starting to do this since we're already in the fourth quarter. And my kids are telling us what they want. So we are actually buying more stuff. I mean, I guess everyone's doing e-commerce now because they don't want to catch the bug going around. We are buying more stuff in the fourth quarter than we did in the previous quarters. So whenever the Q4 variable increases, quote unquote, when it goes from 0 to 1, that means you are in a non-fourth quarter. But then once you go into a fourth quarter, we would expect those sales to go up. And I can look at my scatter plot data here, and I see that that's happening. Every one of these little dots that's way up high, these are all fourth quarters. You can hover over them and see it's 2015, 10. So it's October of 2015. 2014, 10. Fourth quarter of 2014. So every one of these dots that's a little bit higher is a fourth quarter. So I see that and I go, well, I would bet that the Q4 coefficient is probably positive. I can just think to myself and go, during fourth quarters, you would expect sales would be higher than normal. And then I look at my results and I see that the couple times that I used Q4s, those were positive and they were significant. So that's nice. During recessions, and we've got our Great Recession here, 2007, 2008. During the Great Recession, we also had a little one, 2001. During recessions, we would expect people wouldn't buy as much stuff. So when the recess dummy variable increases from 0 to 1, that means that you are now in a recession. And again, we would expect that sales would go down when the recess variable is equal to 1. So if sales are going down when the recess variable increases, then I would expect a negative sign for the recess variable. And I've only done one model with the recess variable in it, but it was negative and it was significant, almost. Not almost, I'll say just barely significant at the 10% level. Not significant at 5% though, and not significant at 1%, but still significant at 10, which is about as high as people are willing to go. So again, you could I would look at those things, look at the R squares, look at the signs of the coefficients and whether they're significant or not. And most of them, at least in the ones that I did here, were significant. Signs were what I expected. If I had to pick which one of these was the best, just out of the ones that I have here, I don't know, again, maybe look at the R squared. That might be my determining factor. 0.928 does better than these other ones. And just barely better than this one at the bottom. So I'd probably end up saying, you could use, if you had to only pick one, I'd probably pick this one. Again, there might be another one that I didn't actually run a regression for. I think, well, those are the only possible independent variables that are here. So I couldn't include another variable besides the ones that are already here. So again, I'd probably say this one is the best, but this one at the bottom did a decent enough job too. Really not far off from this one. And even this one here, the R squared is a little bit lower, but still, you get the sign on T is pretty close to what the other signs were. So not a huge difference between the results of those. All right. I bet the total LSUS hours include graduate hours. Well, I tried not to. I think in the, I was a little nervous about where'd it go? Here it is. I was a little nervous about we talked about not everything else being equal in the law of demand definition, the elasticity definition. We usually expect elasticities to be negative, everything else equal. Well, in the graduate data that we have, everything else is clearly not being held equal because, and you guys probably don't know the history of this, but we started we've had an MBA program for forever, but we moved it online right around 2015, I think. So it went fully online. We had academic partnerships, AP, who you might have interacted with at the beginning of your time here. We kind of contracted with them to do a lot of the marketing for us and some of the organizing part of it. Once that happened, once we moved it fully online, and once we had AP working with us, the MBA numbers just took off. And so the graduate credit hours, the graduate headcount are just going crazy. So if you were to look at that compared to the tuition, there'd probably be a lot of weird things happening, unexpected things happening. So I didn't want to contaminate this experiment or this question, this problem, by including the graduate stuff in there, because it's just a bit of an anomaly. So I just had to look at the undergrad stuff. But even that, it still is a little weird. We still do have this bit of a spike here. We did move, we had the MBA program, and I think some of the other grad programs at LSUS also moving completely online. And we have started moving some of the undergrad stuff online a little bit later. So it could be some of this 2017, 2018, some of this bump, or even go back to 16. Some of that bump might be from moving some of the stuff online. So again, you don't see a huge change in the number of students, but maybe because, well, if I can take this class online and not have to skip work, I could do my schoolwork at 10 o'clock at night and not have to miss work if it's an online class. Maybe that's a better deal for a lot of students, a better option for a lot of students. And so we might not have picked up a lot of extra students per se, but they just find it's more convenient to take these other classes. So that could be what's happening too. I don't exactly know. Anyone else? There probably are supplemental videos that somewhat go along with the assignment. There certainly are supplemental videos that go with the practice problem. I wonder if did last night's Zoom session show up? There we go. So last night's Zoom session is here at the very bottom, and I'll put tonight's here too. So there is chapter 7, practice problem, kind of what we just talked about here. House sales correlation. Someone asked about the correlation of house sales. So that's kind of related to the assignment. Even here, I tell you sample question 2, assignment 3, sample question 1, assignment 3. Importing data, referencing cells, explaining correlations. That'll help with that assignment question. W variables, rounding. Someone asked about rounding. Calculate elasticity and correlation in Excel. You have to do both of those with the housing question. Practice problem number 2. I'm going to use arc versus point elasticity, direct inverse of and function. Practice problem number 1. So you should be able to get some tips for working on the assignment questions with a few of those videos, a few of those supplemental videos. Any last minute questions? I have a list of maybe 30 emails that I need to get through that have just been piling up over the last several days that I need to get through. So, yeah, Thanksgiving, if you look at the schedule, and let's see, is that this? Let me do it this way. Used to be that important dates sheet. Is it still there? Important dates. There we go. We are fall accelerated, online only. And do I already have one? Yeah. No, I guess not. Well, let me show you 2 things. I'll show you the fall regular semester. I gotta save this file too. Okay, and then let's look at that. Now look at all this fun stuff going on in the fall. You got your fall break, Thursday, October 8th and 9th, no class then. You got your Thanksgiving holiday, university offices closed for that, November 26th, 28th. Look at all that time off those full semester folks get. Now let's see what you guys get. October, looking for a fall break. Don't see it. October, don't see it here. Thanksgiving holiday, the university office is closed, but the office I am in now, which is the guest bedroom of our house, is not considered a university office. So we don't officially take time off for this sort of thing. So again, it's 7 weeks. It's an accelerated course, and it's, you know, they just sort of, it's sort of an unspoken rule, I guess, that you're not supposed to technically consider these things to be days off. So my only consolation, I suppose, is that in your due dates of things, I don't know what week that is. Oh, probably around here somewhere. Probably during week 5. My only consolation is that as you're stuffing yourself on Thursday, that is the potential first day you could take the assessment, but you also have Friday and Saturday. So as you've slept off the tryptophan from the turkey, you can have worked on and take your assessment after that. So I guess same thing here. The self-assessment goes from Tuesday through Thursday. So you have to try to get the self-assessment done before you go off on your Thanksgiving plans. So those things are still due, which also means that, you know, we'll still do the Zoom session. I think for things like this that have happened in the past, I think one year we had a Halloween on one of the Zoom session days. And if a lot of people plan on doing stuff, if a lot of people plan on being gone on that Thursday night, we usually have this Zoom session. We can always just move it back, and I'll say, you know, the Zoom session for week 5 maybe will be on Wednesday night and Friday night, same time on Friday. But if a lot of people have issues like that, then we can just sort of come to a collective decision and say, we'll move the Zoom session to Friday night instead of being on Thursday. So, which would be, you know, a bit of a disadvantage for people who might be wanting to take the assessment on Thursday, because they wouldn't have the advantage of listening to Thursday night's Zoom session if it doesn't happen until Friday. And even the people taking it Friday morning wouldn't have access to what we talk about in the Friday night Zoom session. But if it works best for other people, for most people to do it that way, we can do it that way. So I'm pretty flexible as far as that goes. Well, you know, I'm not going out of town for Thanksgiving, so I'll still be here. Anyone else? We went a minute over, but you guys pay me. So if your boss says, I need you to stay later tonight to work on this project, you stay later. And you guys are my boss. So if you want me to stay later, I'll stay later to help you learn some of this stuff about elasticities. But you know my rule. If I say, are there any more questions, and I don't hear anything, that means we are allowed to quit if we are past time. So if there's no other questions, I will shut it down. And again, I'll be checking email all over the weekend. So if you have any questions about anything, you can let me know. Like I said before at the very beginning, if you want to maybe make your day a little bit better, you can go and check out your scores on probably the Module 2 assessment. I don't think I had to do a whole lot of adjustment for anything else, for like the video quizzes or the self-assessment, but there were quite a few adjustments that were made for the Module 2 assessment. So if you check that, there's a 99.9% chance that your score will either be the same or it might have gone up a little bit. So I don't think I had to bump anyone down. Another thing too, you know, for these things that you get 2 attempts at, sometimes people will take a first attempt and they'll get a score that they like. And for some reason they might, you know, accidentally hit a second attempt to start. And I'll go in and I'll look at the results and they'll just be an entire attempt that has no entries at all. And it'll assume that you meant to do that, and it'll assume that your score is now a 0 for that second attempt, and you go in and you're like, oh, I only got half the score that I thought I was going to get. I thought I got a 10 out of 10, and it's only giving me a 5. Well, it's because the second attempt that you started accidentally, it's counting that as a 0. So I go through and I manually look at all of these attempts, and if there's anything like that happening, then I get rid of it. But you know, sometimes it takes me several days or a week later to remind myself to check those things out. So I try to catch them as quickly as I can, but sometimes I'm not very quick at it. So, all right, well, Hope everyone enjoys the rest of your evening and the rest of your weekend. I'll see you guys next week.